Hey, how's it going, Precalc kids? Today we're going to finish up 1.2, so we're going to call this, well, I'm going to call that messed up. I'm going to call it 1.2b. Continuity. Continuity. Okay? What that means is the function continuous? And what it means by continuous is, can you draw it without ever taking your pencil off the paper? So this would be a good example of continuous. So this is definitely noteworthy stuff, guys. You need to know all the types of continuity. Okay. Let's try to draw this one. You're drawing. Oh, dot appeared. Okay, so I take my pencil off. So that's discontinuous. It's removable because it's just one point. If we put that one point back in there, it would be continuous. Okay. Here's another type of removal. What this just says is the point just doesn't exist there. It's just not there. Okay. A jump discontinuity means when you're drawing it, you have to take your pencil off and then start drawing anew. You jump from one to the other. Okay, so it'd be like if you're Mario, you have to jump from here to here. And an infinite discontinuity means, you know, this goes on forever down. This goes on forever up past your screen. So the distance between this point and this point is infinite, so you can't see it. So it's an infinite discontinuity. Okay? So which one's discontinuous at x equals 2? Well, this one's continuous for all points. And this one, you're missing that guy. I just drew a Pokeball. So it's this one. Okay, let's talk about increasing, decreasing functions. This is also noteworthy, guys. Increasing means if I pick 2 points on this graph, no matter where I go, as I get more positive on my x-axis, my y will also be going up. So increasing, think of the graph of this is your money over time, right? Over time, your money's increasing. Decreasing means each point is lower than the next. Money over time, you're losing money. Okay, your money's decreasing. Constant means you're not going up or down. None of it. Okay, so you always have $2 over time. You have $2 in 5 years or 10 years. Now this beast, look at your interval notation, you're decreasing from negative infinity to negative 2. Right? You're constant from negative 2 to 2. And then you're increasing from 2 to infinity. Oops. Okay. Not too bad. Okay. I'm not going to make you write these definitions, but just so you've heard them before. It's increasing if any positive change in x results in a positive change in y. So if x is positive, and then y is positive, so they're both going up, you're increasing. Okay. Now, if your x is increasing, your y is decreasing, becoming negative, that is a decrease. Constant means you're just staying the same. Okay. Okay. Given that we have x squared over x squared minus 1, tell where it's increasing and where it's decreasing. Whew. Let's take a look. Here's what you do. You graph it. By the way, guys, all examples are noteworthy. So we take a look at this picture. Now, I don't know what you guys remember about asymptotes. But this is going to be negative 1 and 1, right? Because those are what give us 0 in our denominator. Right? Okay. So where are we increasing? Well, from here to here, it looks like we're going up, right? So from, I'm going to do my increasers. So it looks like from negative infinity, because that's what's over here, to negative 1, we're increasing. And then from, are we increasing anywhere else? Well, if you look right here, here's an increase too. We're going up. And it goes to 0. So from negative 1 to 0. Okay? And actually we can include that 0. We can't include that negative 1 because we don't have a value for negative 1. Okay, that just goes away. A lot of people say, well, you're decreasing on negative 1. There's just nothing there. Okay. Let's take a look at where we're decreasing. So that means we're decreasing from 0 to 1. And we can include that 0. And then also from 1 to infinity. All the way over here. It's downward. Okay? And we cannot include that one. Okay, so we're increasing negative infinity, negative 1, and then negative 1 to 0. We're decreasing from 0 to 1, and then 1 to infinity. Let's talk about boundedness for a quick second. I'm not going to talk about a whole lot. A function is bounded below. What that means is it's kind of stuck below. It has a lower bound, okay? Or there's like a line below it that it can't get past. If it's bounded above, there's a line above it can't get past. It can't break through to the ceiling. And some are bounded both above and below. They're stuck in the middle. I mean, if you ever see a curve that looks like this, it's bounded top and bottom. Okay? Okay. Let's talk about local and absolute extrema. This is going to be noteworthy stuff, guys. Okay? A local max. Okay? A local max occurs if your values of y go from increasing to decreasing. And this is going to be a really important calc concept. So what happens is, you have a roller coaster, you're increasing, 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 you stop, you decrease, 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 decrease. Draw a roller coaster here. Okay, you roller coaster. So this point right here, when you switch from increasing to decreasing, is a local max. Okay, it's a vertex. So that means your local min would be when y goes from decreasing to increasing. Okay? So that one looks a little bit more like this. You're decreasing, and all of a sudden you start increasing, right? So you're still on this roller coaster. And you're going to be decreasing, and then all of a sudden you'll start increasing again. And that's going to be a local min. Again, that's a vertex. Okay, it's a top of a hill or a bottom of a hill. Top of a hill is a max, think about it, because you're taller. Bottom of the hill, valley, is your min, because you're at low point. Okay. If it's a local max, here, let's just take a look at one. Okay, find the local max and min of this function and find out the values where each one occurs. I have to graph it, so hold on a second. I graphed it. Now, tomorrow or next time we see chart, remind me to show you how to do this on your calculator. I'll do it quick though. So your max is local, not absolute. Well, that's a min. It's going to be a min. It's this top of this hill right here. Okay? So we're going to have one of those. I'm going to finish this tomorrow, guys. So I'm just going to skip it for right now. And we'll do that in class when you guys have your calculators. Deal? Deal. Let's talk about symmetry. If something's symmetric, it means you can cut it in half, fold it, and covers itself, right? Right. Okay. So, if you are symmetric to the y-axis, what that means is your f of negative x equals f of x. Right? So if f of negative x equals f of x, then you're symmetric to the y, you can fold in half, and it's even. Okay? So again, this guy can cut in half, fold it, and covers itself. Right? Right. Remember, you can pause anytime. You can pause anytime. While you think about that one. Now, if you're symmetric to the x-axis, what that means is your f of negative x equals negative f of x. Okay? Just kidding. It's symmetric with your x. What that says, if xy is on the graph, then x negative y is. These aren't functions, so we aren't going to worry about it too much. But when you look at the graph, you should be able to tell. Okay? Now, if you're symmetric to your origin, what that says, I can take that middle point, I can rotate it around, and I can graph it on itself. Okay. You guys want to try something? Like this guy. It's symmetric to the origin because I can take it and spin it onto itself, right? Same graph. Okay. That's what symmetric to the origin means. And also what that means is that your negative f of x equals f of negative x. Okay? And what else it means is that it's odd. It's a weirdo. Okay? Okay? Let's do this. Okay. Tell whether this is odd, even, or neither. X squared plus 3. Well, if you graph that, it looks like this. So yes, it is a function. Noteworthy stuff, guys. Now we have to say, is it odd, even, or neither? Okay? Now remember before, if it's even, f of negative x equals f of x. If it's odd, negative f of x equals f of negative x. So basically what we need to find is f of negative x, f of x, and negative f of x, and see if there's a relationship. First, let's find f of negative x. So what that means is, wherever I see an x, I'm going to plug in a negative x. Okay? What's negative x squared? Well, it's just x squared. Okay, so I plugged in negative x for my x, and I saw what happened. Now f of x, here I'll use a different color. My f of x is just, well, x squared plus 3. And my negative, I have some of these colors here. Let's do good old-fashioned red. Negative f of x equals, well, you put your negative out in front, right? Okay? So do any of these two equal each other? Yeah, these two do. So my f of negative x equals f of x which tells me I am even. So this is even. Okay? We're almost there. Have to pause for time. Last two examples and I'll let you guys go. I understand this is a long one. We'll make it through. So what about this one? Same as before. Odd, even, or neither. We already have f of x. Now we need to find f of negative x. Okay? And negative f of x. Well, f of negative x, we plug in our negative x cubed minus 2. Which is, well, negative x to the third is still negative x third minus 2, right? Now, for this one, we put the negative in front of our whole function. You get negative x cubed plus 2. Okay? Now, the question is, do any of these things equal each other? Is your negative fx equal to f of negative x? No, so this is neither. Oops. Way to spell, Mr. Twilliger. Way to spell. Yeah. Okay. Let's take a look at this one. That one's going to be neither, too. Let's just change this so it's f of x to a third. So we need to find negative f of x. We need to find f of negative x. Okay, so I plug in negative x to a third. And that just equals negative x to a third. Okay, now this one I put the negative out in front. And I get negative x to the third. So these two are equal, right? So that tells me I'm odd. Okay, I'm sure there'll be questions on this. Don't worry, I'll answer them. Enjoy.